In the last video we introduced complex numbers and we learned how to add them together, to take them away from each other and to multiply them. And there was nothing all that strange about any of that. But today we're going to try and do divide. So here's two examples here, dividing complex numbers. And there is something fairly strange in this, and that we need a trick, a little algebraic trick we need to help us along. So let me introduce that. It's called the conjugate. I have a bit of trouble spelling this. The conjugate there, and it's when we have two different types of numbers. It can often be x and y, a number and an x, or think of it like a number like say 3 plus 2x. That's when I say a number and x, I mean. A number without x and a number with x. Basically any two groups, any two numbers basically that are different. I guess you could have them just be two numbers as well. In this case though, and what we're going to stick with here is, let's just think about an example, 3 minus 2i. So here is a real part and an imaginary part. So the conjugate of this, let me write this here, 3 minus 2i, and its conjugate would be 3 plus 2i. It would just be, now this would be the imaginary, the complex conjugate, and the imaginary part conjugate. It's when we change the sign in front of the imaginary part. Now you could change the sign in front of the real part and that would be a different conjugate, I guess. It just wouldn't be useful in this. Now let me show you what's so useful about this conjugate. When we multiply it together. And from the last video, we multiply it by just as always, two brackets. We get 3 by 3, we'll leave 9. Now here's where it gets interesting. This is why I picked this conjugate. This is why we use it. The 2i times 3 minus 2i times 3, 3 by plus 2i. We get minus 6i and plus 6i. They cancel. Minus 6i plus 6i, they cancel. That will always happen when we use conjugates. When we multiply something by a conjugate, that always happens. And the last part will be minus minus 4i squared. And here's the other interesting thing. So this will happen with all conjugates. We'll get the first one squared and the second one squared. First one squared, second one squared. Well, minus the second one squared. But what's interesting in complex numbers, when we have a imaginary number squared, this is 9 minus 4 multiplied by minus 1, which is 9 plus 4. We get two real numbers, which is 13. So instead of having a real part and an imaginary part, we're now just down to one real part. So that's the conjugate, and we're going to use that to solve dividing. So I'd love you to pause the video now, see if you could try these questions yourself, and use the idea of conjugates, see if you can figure out where or when to use them. If you do get stuck, don't worry, just replay the video and the trick, I'll show you the trick quite early, then you can pause it again and see if you can solve it all. Okay, so I'll just jump in and we'll go, part 1 is 7 plus 4i divided by 2 minus I. Now you might ask yourself, okay, well, how do I use this conjugate? Where is this trick? The only real problem with dividing is the bottom row having an I in it. It's just difficult. We'd like one thing being on the bottom row. Then we can just divide it into both numbers. So this is difficult, having two things. Not only two things, but they can't be joined together really. This is real and this is imaginary. So here's the trick. We multiply it by its conjugate. So really I'm just multiplying the bottom row. I wanted this on the bottom row. This is on the top row merely because I need to balance it somewhere. Otherwise I'm cheating. I really just want this on the bottom row. But obviously I need to put it on the top row because now I haven't changed anything. This is 1. 2 plus I divided by 2 plus I is 1. I haven't changed anything. I can do that whenever I want. Except when I multiply the bottom row, I get something really useful. So let's multiply this out. This is equal, top row will do is 14 plus 7i plus 8i plus 4i squared. Yeah, I hope you're following there. 7 by 2, 7 by 1, 4 by 2, 4 by 1. all of this is over. Bottom row is a lot easier. You'll get used to these in conjugates. I'll do it slowly this time though. It's 4 minus 2i plus 2i. This is always going to happen, so you can even skip writing this. I'll do that in the second part. I'll skip writing that part. Again, we can do a shortcut here as well, but for now I'll write minus I squared. It's always going to be minus an I squared, so it's really just going to turn back into a plus for me. Now this is equal to, let's clean this up. We have, I'm sorry, I'm missing a squared here. 4i multiplied by I is 4i squared. Okay, so 4i squared turns into minus 4, because I squared is just minus 1. So 14 minus 4 is 10. 7 plus 8 is 15i. Bottom row, that's 0 i's, and we get 4 minus 1. So 4 plus 1 divided by 5. We can clean that up again. 5 just goes into both things. So we just get 2 plus 3i. That's it. That's how we've just divided two numbers, two complex numbers, and the answer is a complex number. Once again, I'd love you to pause the video and try and do part 2. I'll rub this out. Actually, I didn't need to rub this out, did I? I could have fit this in the same space. Too late now, I can't put it back up. So I'll just jump into part 2. Well, again, I'd love you to pause it. It'll work out the exact same. It's a little more awkward of an answer. It's not as perfect of an answer, but it will work out the same principle. So ask yourself, what do I need to multiply this bottom row to make it easier? And it's just a conjugate. Now, this idea appears in other parts of maths. It can often appear when dividing fractions. If there's a number without x and a number with x, you could use this idea to simplify that out a bit. But of course, if we multiply the bottom row by the conjugate, I better multiply the top row, otherwise it won't be fair and balanced. So let's multiply this out. Top row we get 18 minus 3i minus 12i, and yeah, that's right, plus 2i squared. Bottom row, 3 3's are 9. The 3 by 2 and 3 by 2 will cancel, so we'll just get minus 4i squared. Well, that's just plus 4. I can get there quickly. Let's clean this up. We will get 18 minus 2 is 16. And we get minus 15i all over 13. This is okay as your final answer, but often they do ask, I'll write it over here, they often ask you to write your answer in the form of a plus bi. And then they say something where a and b are elements of maybe q, often in this case. Remember what q is, that's just a fraction. So in this case it's 16 over 13 minus 15 over 13, because of course 13 can divide into both of them as well, it's just not evenly. Sorry, 15 over 39. That's our final answer. That's our final answer. They could have also wrote or here, by the way. This is an element of the real numbers. It's also an element of the quotient numbers. I can't remember what that's called. So that's how we divide two complex numbers. Very simple. Once you do this trick, it's really just multiplying, some adding together in here. So what I really recommend you do is you practice 7, 8, 10, 20, 30 of these questions. They're quite simple, quite short. It'll get you, give you lots of practice multiplying complex numbers. It'll give you lots of practice dealing with I squares. And of course, it'll give you practice dividing complex numbers. Okay, until next time, thanks for watching and goodbye.